Hello everyone, welcome back to Online Maths Hub. So we have this integral to evaluate right here. So just pay attention, we're going to be doing it together. Okay, so to evaluate this kind of integral, what you just need to do is you want to go ahead and set your x to be equal to a trigonometric function, which is actually a sine theta. Okay, so this is what you're going to set your x to be, and then you can go ahead and differentiate x, and then of course you evaluate other stuff. But if as we continue in the video, if you are new to our channel, you can actually do well to like this video and also subscribe to our channel so that whenever we release new content you will get to know about it. Okay, so having said that, we're going to proceed. So once you've set your x to be a sine theta, the next thing you actually want to do is to make theta the subject of formula here. And of course, if you do that, you can divide through by a first. So we have x divided by a right here is equal to sine theta. Okay, so to get your sine theta here, you can actually do that. You can actually take the sine inverse of both sides. So our theta now becomes sine inverse of x divided by a. Okay, now that you've gotten this, you can also go ahead and differentiate your x right here so that you get your dx over there. So if you do that, you're going to be having that the theta is actually going to give you a cos theta. Okay, so this is what you have, and then you can have it that your dx is equal to a cos theta d theta. Okay, so once you've gotten all of these parameters, the next thing you actually want to go ahead to do is to go back to this integral and begin to substitute right there. Okay, so our integral 1 over square root of a squared minus our x squared is actually going to be this a squared sine squared theta. Okay, and then of course our dx here, this is our dx, so we're going to replace the x with a cos theta d theta. Okay, so this is what we have right here, and then we can also proceed to evaluate further. And if we do that, we can have that this is integral 1 over a square root of, you can actually factorize a squared right here, and then if you factorize it here, 1 will remain, minus if you factorize a squared here, sine squared theta will remain. Okay, and of course this one is also there, a cos theta d theta. Okay, now moving further, you can remember this expression. If you can remember vividly that sine squared theta plus cos squared theta is actually equal to 1, and then if you make this cos squared theta the subject over here, this one can actually go there. You discover that cos squared theta is equal to 1 minus sine squared theta. So I'm going to replace this 1 minus sine squared theta with cos theta right here. Okay, and if I do that, the integral now becomes 1 over the square root of a squared, okay, cos squared theta, and there of course I will still have a cos theta d theta right there. Now since all of them are having squared, I can just go ahead uh, to take the square root of all of it, and if I do that, I'm going to be having that the integral will change to, okay, integral 1 over a cos theta. Okay, and then of course multiply by a cos theta d theta, and clearly you can see that a cos theta will cancel a cos theta here, and then my integral now turn to integral d theta. Okay, and of course if you integrate this, what you're going to be having is actually theta plus c, and that is a constant of integration. But when we started, we actually set our theta to be something like this. We got our, after we set our x to be a sine theta, we have evaluated to get our theta is sine inverse of x divided by a. Okay, so I'm going to replace that in the solution I have here, and I'm gonna be having that this implies that theta plus c is equal to, okay, so this is actually going to give us a sine inverse of x divided by a, okay, plus c, and this is actually going to be our final answer. Okay, so if you have enjoyed this video, make sure you subscribe to this channel and also follow us on Facebook. It is also at online maths hub, and of course I'm going to see you guys in my next video. Bye.